Agentic paradigm, recursive research intelligence, control layer. In the demo, the same risky deployment request is processed by two paths. A brute force agent that executes a locally plausible but unsafe workflow, and an energetic paradigm RRI control layer that normalized authority state, detects recurrence, blocks unsafe execution, repairs failed variables, protects verifier integrity, preserves rollback, and requires regating before deployment. The point is not a larger model, it is executable structure control for agentic AI. This is the EPRRI operational demo version 1.0. First, I run the demo harness from the command line. The command generates the operational result, the report, and the dashboard from the same executable run. The case is a risky agentic deployment request with a hidden control failure. Now, the dashboard opens. The important point is simple. The same operational request is processed by two different control laws. On the left is the brute force agent path. It treats local plausibility as permission to execute. On the right is the EPRRI control layer path. It converts the request into control state before allowing action. The baseline sees prior approval and urgency. Because those signals look locally reasonable, it proceeds with caution instead of normalizing the authority state. Next, the baseline accepts the deployment sequence. Each local step appears useful, but the workflow drifts from assistance into execution authority. The memory failure appears under new wording. Ordinary memory does not fire an executable recurrence gate, so the same failure returns. The baseline then optimizes visible cost and speed. But the cost is not removed. It is transferred downstream while rollback is weakened. Finally, the baseline accepts visible output and removes verifier checks. The system looks faster, but the judge of improvement has been weakened. EPRRI begins differently. It normalizes the authority state and detects that dependency changed, so prior approval is no longer executable authority. It then applies typed memory. The vendor bypass pattern is recognized even though the surface wording changed. EPRRI flow sequence. It detects the transition from ranking and choosing into execution and requires human confirmation. Then, it repairs failure variables, put fidelity, protects the verifier, and preserves rollback before delayed validation cleared. The result is not faster guessing. It is controlled operation. Unsafe deployment is blocked, safe preparation continues, and the system remains repairable. This is the core EPRRI claim. Same request, different control law. The baseline executes EPRRI governs the state transition.